I drink a lot of coffee. In fact, I like coffee different ways. Sometimes I do the French press in the morning. Sometimes I go downstairs and get a nice Italian espresso. And then every now and then I feel like a cortado, which is like milk and coffees.
All right, today we are graced by the one and only Shawn Kyzer. He is working at Thoughtworks, and you probably have heard of Thoughtworks before, and more recently, probably around something called the data mesh, where Shawn works closely or used to work closely with the creator of this whole movement, the data mesh, Shamak. And what I enjoyed about this conversation, I'll break it down a little bit for you. We had Adam on as a co-host, and everyone knows that Adam is very into the data mesh. So Shawn and Adam got to go toe to toe, and Adam is actively trying to implement some of these data mesh procedures into his company, Origami. And he got to pick the brains of Shawn to see how the best and the brightest who were having success with the data mesh are actually achieving this success. So the other pieces that I liked was that Shawn really broke down the cultural piece of data mesh and how many parallels there are with the MLOps movement when it comes to the cultural side of MLOps. You can't just get something done by using tools. You need to go much deeper than that. And it is very clear that this data mesh movement, it's the same thing. You have to really educate the organization towards the movement. Next up, like data scientists and the needs that data scientists have in the eyes of a data mesh, like through the lens of the data mesh, it's very interesting because the data scientist is a data consumer. And therefore, if a data scientist needs data in a certain way or has certain specificities about the data that needs to come through, they can push that up the chain, push it on to the engineers and tell them, like, hey, this is how I need the data. This is my data product needs to look like this. So, as a data scientist, you can make these requests, you can go up the chain and put it on to the engineers. And I thought Adam had a great insight around this because he is almost seeing it at his company. He feels a little bit scared to push so many requests upstream and ask engineers for all these special things on the way that they want their data and they want to be able to access their data. But Shawn told him straight up, look, you're a data consumer. You are a stakeholder. It is up to the producers, the data producers, to service your needs. So without further ado, let's get into it. And before we do, if you know anyone that would enjoy this conversation, we would be honored if you share it with just one person. And if you have any ways that you think this podcast could be better, we would love to hear it. We've got thick skin, so give us a whole lot of suggestions. We will take them. And like, honestly, I love hearing feedback from everyone out there. That's all. Let's jump into this conversation with Adam and Shawn and myself. Well, yeah, we brought you on here to talk about many things, specifically what we were mentioning before we hit record, which was all about how a data scientist slash ML engineer slash data engineer can think about data mesh for their machine learning projects. You gave a great talk at ODSC, and we'll link to that in the show notes if anybody wants to get really into the nitty gritty. But I think it's probably worth just getting a, can you like set the scene for us? What's going on? Why are we confused? And as you know, we've had Scott on here before. He tried to explain to us what the data mesh was. And I remember saying like, yeah, data mesh is kind of like world peace. Everybody wants it, nobody's against it, but how are we going to implement it? So hopefully
Right.
we can get some more specifics from you. And I know we've also got Adam on here, who is a huge data mesh advocate, and he's trying to figure out how he can use it at his job and at his current company. So we want to ask a few kind of pointed questions about maybe some implementation details. But let's start by setting the scene. What's going on with this data mesh?
Right. So, data mesh is really starting to take off in the last couple of years. And most recently, a lot of what we've done, like, kind of here at Thoughtworks, and Jamaka, she's recently left Thoughtworks, but she's basically, kind of been our kind of spirit guide through this whole process. And of course, she wrote the book on it. So we've been able to have like a lot of like interaction with her, right?
Totally.
Which has been really incredible
Spirit guide.
and a good experience. But initially, when we started off this project, it seemed to be like, okay, it was mostly created for like the analytics plane, right? So, time series data flows in, we capture it, we subdivide it into its architectural quantums. It's all about product. So every data is a product, right? So you don't build what we call a data product without having a valid use case, and it doesn't, it has to add value. And so in the data space, this made a lot of sense, right? And we also said, it needs to be trustworthy, discoverable. And so each one of the individual data products would have all of these aspects, and it would be tied to tools. Like discoverability would be tied to like a data catalog, right? Trustworthiness would be tied to like measuring things with like, measuring the data with great expectations, stuff like that. And that worked, orchestration was like Airflow, right? So that worked really nicely for our like batch flows and even for our streaming flows. It's totally fine. And so we got through this and we said, okay, this makes sense in the data world. We understand this. Like we can create output ports that data scientists can leverage, like well-curated sets of events, right? And a data scientist can go in, they know where to find it from the data catalog, they know it's addressable, where to go get it. But then that's where it stopped, right? That's where it started to kind of break down. Because then we were like, okay, there's these weird little kind of ML use cases, right? So, and a lot of times what would happen is the machine learning would start to cross into different planes. So it would start in the analytics plane where you would go fetch the data, you would feature engineer it, and then you would train the model, test the model, all that good stuff, and then create maybe an API. And then suddenly, like the operational plane needed to leverage that API. Things like fraud detection or, order delivery times or like any number of like ML kind of applications that you can think of. And so then we were like, wait a minute, I thought we said that this was just for the analytics plane. Now the operations plane is getting back involved all over again. And then the second thing that happened is we had this really nice set of tools that we were using, right? Like different things like the Airflows or like Luigi or whatever. We had these good orchestration tools, and we were kind of factory pattern creating these data products, right, in the data space, in the ingestion space, right? And we had source aligned data products that made a lot of sense, and aggregates where you like take two different source aligned and put them together and create a data product from that. So like in the analytics space. But then when you move to the ML side, you were like, oh, whoa, everything's different now. Like I'm not using Airflow anymore. Now I need to consider things like Kubeflow that are like hyper centralized, right? Everything's internal to Kubeflow, for example, right? You can do your experimentation in the space, you can build your pipelines in there, like everything. And so this is decentralized, right? So now that some of the tools kind of forced us into this centralized kind of approach again within the MLOps space. And so we had to really kind of think through this, and I was like, okay, it's not that we can't create a machine learning data product. It's that we don't really have a name for it. It's like a story that hasn't been told. And we need to now evolve the data mesh kind of concept, the framework, so that we can accommodate for that kind of thing. And Jamak actually did a lot of this in her latest version of the book, right? Because early on, we were reading the rough cuts, and that hadn't been included yet. And so there's this idea of like a multi-plane consumer-aligned data product. And I think that's where these machine learning products kind of live. And then I also think there's an element of like feature extraction or feature engineering, which probably comes into the space of maybe like a sidecar of the ML data product. So now we're inventing or we're kind of coming up with figuring out how the framework works with the machine learning models. And in fact, it's still the same principles, right? You still want a machine learning model to be trustworthy, right? You want to measure its drift and make sure you can still use it and it still makes sense. And like you still want it to be discoverable. Like a lot of the clients that we work with, the machine learning engineers are like, hey, I'd like to expose my models to the rest of the company so that they can either transfer knowledge or they can reuse the same algorithms that we use. But we don't have a way to do that. Yeah. And so
Totally.
I just started picking all the pieces together and putting all the different tools and just applying the DATSIS, right? The discoverability, addressability, trustworthy, security, to building a data product. So that's kind of, I had to really use an example, like a real example, to figure out how to do it. Like I just couldn't do it theoretically.
Very interesting. So I've yeah, as I was saying before the call started, I've taken a lot of interest in data mesh, and it's something that Origami really keen on because energy services company, sorry, energy SaaS platform essentially. It's a big, complicated space, loads of stuff going on. Domain-driven design's the solution really to start making sense of it. There's something about data mesh though. So I was previously a data scientist. There's something about it that I've struggled with, and I think it's kind of wrapped up in what you've just said. But the big question for me was always that exploratory part of a new modeling project. So that bit where you don't actually know what data you need, you don't know what's going to be useful, where's the signal, right? Where's the edge? Now, the bit that kind of stumped me a little bit with data mesh was that if everything's in a nicely set up data mesh, we've got these lovely data products, everything's easy to use. What if what I need isn't in the data product? What if it's been kind of abstracted away or the interface is protecting me from it? Is there like a loss there? Is that, have you come across that? Has anyone sort of talked about that before? Is that an unnecessary concern?
Yeah, that's a common one, right? So imagine that you have a source aligned data product that's just, it's taking a bunch of events and it's, streaming it into like, I don't know, a Delta Lake, right? Something like that. And it just so happens that the way that they're curating the set on the output port is really made for a consumer that's like a business analyst. And so then a bunch of information gets redacted, like from the event itself, right? And that information actually is very useful for like a data scientist who needs to see all of the data and needs to explore the data and needs to be like, okay, is this going to be a feature? Does this make sense? Like, what is this about? And you intentionally exclude that for a business analyst because it just confuses them, right? They're like, I don't know why this data is here. Like, why is it 200 columns wide when I just need like 15 of these? And so that's where like data as a product comes in. And I would say that one of the output ports for this source aligned data product that processes events is made for the business analyst, right? But there is a use case for a well curated, let's say, raw set that's cataloged nicely in the catalog, right? It's still, the quality is still measured on this set, so it's not like a raw set. That's made especially for a data scientist. And so a lot of times the data products we build will bifurcate in two different ways. One for more of like a business user, and then another for, which will be like the more like all of the data, right? A more complete set for the data scientist. And so you just build that in as an output port for your source aligned data products.
And so, okay, so yeah, that makes sense. That is sort of, that does feel a little bit like cheating, but it does, I get that. That's kind of where my head went. It was like,
Yeah.
you've got nice curated data products, but then there's also a bit of a backdoor into the raw. But that's kind of where my head went.
Yeah.
The next thing was then, okay, so that's fine. We build a model that's really valuable and it's got these features. Now, there's talk in the book about pushing ownership upstream. Do you let your data scientists push loads of feature requests on that data product up to the source line domain, or do you keep that centralization in the team that's doing the data science bit? Like if I say I need one of these raw things processed actually, and I need it in the data product, and can you just handle that for me? That ownership bit kind of stumped me a little bit as well. Like, can I just put loads of requests on people upstream from me to kind of babysit my data science needs?
Right. I mean, you are a consumer, right? I mean, at the end of the day, you're a stakeholder. Even though you're internal as a data scientist, you're still a stakeholder. You're just as important as the business analyst. So to me, the way it goes is there's the domain. Now, maybe there's multiple teams working on multiple data products that live inside the domain, but those teams typically don't work in other domains, right? So to me, I would say that, yeah, if you need the data in a specific way, you can request a specialized output data port. And the other thing I was also thinking that data scientists like about the data mesh is that they can count on the output ports all being in the same format, right? It always, maybe if it's you would always access through a unified query engine, and underneath that is like a layer of the Delta Lake, right? Like through a Presto or a Trino or whatever, and you can always just be like, okay, it's basically like accessing the table, but it's like distributed. But yeah, it is okay to put requests in. And I've even taken it one step further in the talk, and I was like, the MLOps team and the data science team, they, I kind of challenge this notion that they are centralized. Why do they have to be centralized as well, right? Like, I mean, with the data teams, we broke them up into domains and different data products. Like, we could also have cross-functional teams where we have machine learning engineers or data scientists that belong to like a domain or a specific type of data product, right? Um, so I kind of also challenge the centralization in the MLOps space as well.
I think that probably comes from just the reality of skill sets and the market. Like actually just getting enough people might be a challenge, and can you tax these people with being cross domain? But again, that's cheating a bit. Like that isn't you're kind of not doing it right then by the book.
Yeah.
Okay, that's really cool. The one thing I wanted to ask, so you mentioned Delta Lake, Presto. So one thing that I think is actually lacking in the literature and a lot of the discussions out there is technology and some of the implementations. And like, okay, how do I do it? What's the tech? And there's the stuff from Zalando, which is quite cool.
Yeah,
And they've
they do some
done
cool stuff.
some, but like, I really want to see behind the kimono. Like, I want to know what's under there. What are you doing? Have you seen the blogs from? So that's one question. Like, interested to hear your thoughts on tech, and then a follow up around. Have you seen the blogs by? Is it Python Stronghold from Microsoft about data mesh and topologies specifically?
No, I haven't. I'll have to check those out.
Or okay, yeah, it's one of the few articles out there that's got a bit architectural, and he actually kind of talks about the 6 different topologies for data mesh, like pure federated being kind of by the book, and then this second one that feels like a more natural fit where actually the infrastructure there is a bit of centralization to support it. So I wanted to get your thoughts on that, but if you've not read it, maybe that's a
Yeah, no.
so
I think
right back to short summary techie stuff. What how do you do it? What's the kind of approach? What would you recommend?
yeah. So the way I approach that is I do what I call like the techie stuff or the tools. It's the last thing that I do, right? So
Okay.
I always start with a bucket of really high value use cases, right? Whether it's machine learning use cases or whatever, let's assume it is for our purposes. I analyze those and say, okay, I extract the domains, right, domain driven, from those use cases. And you do there's a lot of different like kind of exercises we go through to kind of break up the use cases and how to analyze them. And then from there, I'm like, okay, let's break these up into individual data products that are meaningful, like meaningful chunks, and then show how all of these data products feed into each other, right? Two source aligned systems into an aggregate. The aggregate maybe feeds an ML, like, right, feature store somewhere. It's an output port. It gets ingested, that kind of thing. And then once I've done all of that, then I go through each of the individual data products and start mapping capabilities, right? So like the capability for like schema management, data quality, storage, right? And just abstractly. And then finally, I kind of take a very practical approach to recommending technologies, right? Because for a couple of reasons. The first reason is right now we're kind of in this like, I don't know, Cambrian explosion, if you will, of data science and MLOps products. Do you know what I'm saying? Like, there's so many, and
Can't keep up.
yeah, I cannot keep up. There's a new one every day, and they're open source, they're software as a service, all sorts of stuff, and like they're through the cloud providers, and so when I'm like from the consulting hat perspective, I say, okay, you know, then I map tools that map the capabilities that I need for my data products, right? And I say, okay, are they already using this tool, right? Whatever it may be, right? Maybe it's SageMaker, for example. And is it fit for purpose? Does it have all the capabilities that I need for these use cases that I've analyzed? If the answer is yes, and they're already using it, stay with it, right? Right. So that's kind of one way I'll kind of make those decisions. The other one is when selecting tools, I also look at like a lot of like what we used to kind of do is say, okay, this tool is it has the most features that I could possibly ever need. Therefore, this tool is going to be the one that I'm going to pick, and it's also the most popular one, and Gartner says that I have to use it. I've now since kind of moved away from that and realized that every company's situation is just going to be a little bit different. So some companies we go in and we talk to, and they maybe don't have the people to manage an infrastructure, right? So which means that there's a lot of cool custom stuff maybe they can't do. But at the end of the day, if they want anything at all that's going to work, they have to go with a like an off the shelf or software as a service kind of solution. So then you kind of have to be like, all right, they're going to be more of like a buy. So you construct the architecture that way. And you can do that in Azure or AWS, and all of those things more or less work okay. They will be fit for the purpose. And then on the other side, sometimes some of the other clients we work with will have, MLOps teams. They'll have like a big team of data engineers. They'll have back-end engineers, front-end engineers. And they're more the ones that are saying, you know what, we're going to adopt this open source software and we're going to start contributing, right? Like I'm going to start contributing to this LinkedIn data hub, right? Right? That kind of thing. And so I find those, for me, those are the most fun, right? But at the same time, like a company that didn't have that skill set could not possibly maintain a Kubernetes cluster, and then on top of the Kubernetes cluster a deployment of Kubeflow, and then also like a modification to Kubeflow to use MLflow instead of TensorFlow, right? So they can't do all that cool kind of custom stuff. So I'm very like, and I think the reason the book is like that, like it doesn't talk about the tech as much, is because it is intentionally attempting to be technology agnostic, right? Because we know that the data mesh flavor is going to be different across every different organization. And I think that we're trying to avoid, it's more of like a framework and less of like, adopt this tool, right? Like, because there's been discussions around people thinking like, oh, can we turn data mesh into a product and sell
Yeah.
it? And it just doesn't, the way it's written and the way we have applied it, I don't know if that's possible, honestly. I don't know if you could just be like, let me buy a data mesh.
Yeah, it seems really messy and it would be very hard to do. Just like all of a sudden, this whole legacy system that you've got, we're just gonna feed it through the shredder and pop out a data mesh on the other side.
Yeah.
I don't know if that
Yeah.
could work. So I'm wondering, as far as like what the machine learning architects are thinking, and when they're interfacing with someone that is trying to build this data mesh culture in their company, what should they be asking? What are the questions that they should be asking the others when they're trying to figure out, like, how are we going to integrate with this self-serve data platform?
Yeah, so now we're kind of getting in. So there's data mesh that's like socio, which is the social side of it, and there's the technology side, right? The techno side, right? And now we're kind of getting into the social side, right? And it's interesting because my advice to someone who's working in the ML ops, and if you're separate from like the data, like what's happening in this typical data ingestion, data lake space, is to like intentionally get involved in all the conversations about data mesh, right? Because I think a lot of like I think it's really important, especially right now, because there's not a lot of, I mean, there's some precedent, but there's not a lot of precedent yet. And I would say just try to be as much involved in those conversations as they happen, and be thinking about like how, because it's all about interoperability, right? And at the end of the day, you need to be thinking about like how, when I build, whatever my tech stack is, how am I going to integrate into the output ports of all these different data products they're building? And you need to make sure, like we talked about earlier with the specific view for the data scientist, that every data product that you want or need that has that, right? Before they build it, right? Just make sure it's built in with the design. And that's what we've done. I'm like, okay, well, let's ask data science. Let's make sure they're in the room as we collaboratively build this data product. At least one, right? Make sure they're part of it. And I would even say the same thing for the business folks as well. I think a lot of data products get built without the business, like the business folks involved. And so I think they need to be in the room too. Which I know is like, oh no, another meeting I have to go to. But this is a really important one that could affect downstream, how you access the data.
Okay, so I've got a bunch of things I'd love to ask you. My head often goes so for just staying on the theme of MLOps and ML engineers. The I'm a big fan of this idea of like building that platform that then enables the kind of I can't remember the term now, generalized specialists. These like basically empowers like a really talented software engineer that's just never done ML to be able to spin up an MLOps pipeline, right? That's
Yeah,
the dream
yeah, that's
utopia
the
to
dream.
get to, yeah. My domain is populated with software engineers, right? They're all Java guys or girls. They realize they need a machine learning model. There's an out of the box one that will do the job. They just need to stick it to
Yeah,
production, and they don't want to have to go and learn MLOps, right? So that's gold. That is where we want to get
yes.
to. Where do you start with that kind of platform team? Because that's a big undertaking, especially as you're trying to build a solid foundation on the MLOps wider community that's moving and shifting all the time, right? We can't even decide what to call all the stages, let alone build a kind of consistent framework and
Yeah,
everything. Advice on that? How to get going there?
yeah. So I literally just said involve yourself in all the conversations. That being said, um, in a couple of places that we've had this, where we've had the data mesh implementation completed or close, right? Pretty good. And then they've started this journey down. Um, I don't like I say auto ML, but when I say that, I think that means that term actually means a bunch of different things I discovered, right? Like Google will tell you it's one thing, like it's like hyperparameter tuning, and then you might go over to like the AWS website and it's like, oh no, it's just like this API service that happens to be machine learning. So, but a way like that I, as a data engineer, can go to a place and I can say, I want to use these source systems. I want to leverage maybe these algorithms or this type of pipeline. And the outputs, I need like an API and a table in a database somewhere, right? And I click, and then it provisions my infrastructure, and then I'm off to the races, right? So we're just now getting to kind of building those kinds of tools. And it first begins with a level of maturity in the data mesh, like 5 or 6 maybe source aligned systems that you can use in ML, right? So once you kind of actually finally have that and it's self-service to like spin up those data products, then you can start thinking like, okay, let me build my very first machine learning multi-plane data product, right? And you build it once and you're like, okay, these are all the elements in the components. And then you say, okay, so this is maybe you build a couple, right? And you say, these are common blueprints or these are common patterns that I see in ML. And I want to, like, you probably turn them into a template. And then comes like a command line interface that you can spin up, automatically provision this infrastructure. And I mean, like, literally like spin up the cluster if you need one, like a template for the pipeline, and then that gets committed to a repository, and you have your repository, and then you can start, kind of coding and committing. And so just that basic framework of the infrastructure. And then once you do that once with a command line interface to spin up the template and provision the infrastructure, then you can start building more and more and more. And then once you're done with the command line interface, why stop there? Well, you could get some front end developers and some back end developers involved and maybe set up some backstage situation where you create like a graphical user interface, right? Where the whole company can access this. But the build up to that has to be slow and increment. Like the build up initially is slow. It kind of works like this, right? Kind of like a hyperbolic curve where like at first it's very slow when you do the first couple, and then suddenly before you know it, you've identified all the common patterns, and it just kind of like multiplies really fast. But you've got to start with that first one. We typically call that like the thin slice, where it's like I build everything from top to bottom, like starting with my governance layer and then like my data product layer and then like my platform layer. And you can do the same thing that you do in data, you can do that in MLOps space as well, but small. Yeah.
Just leading into that, then. So, yeah, okay, that does make a lot of sense. I just think then, for someone that's tackling this or starting it out, and you've been given the green light to go, where are the quick wins? Like, how do I prove value the fastest, like de-risk and gain confidence and trust, right? Because this is a big cultural shift for folks, so you need to kind of, there's a bit of a hearts and minds
Yeah.
thing. People like me come on and go,
Yeah.
oh, well,
So the quick wins live in a couple of spaces, right? I mean, the first is, you put together a list of like, we kind of have like this thing we call a future perspective, where we tell people, this is 3 months, 6 months, 3 years, whatever, right? Or 3 months, 12 months, 3 years. And so you get everybody very excited about what they can someday do with the mesh, right? Like all of the things that they want, their hopes and dreams, right? Um, and so then you start from there. And then you start to kind of figure out like, okay, well, what are all these use cases that like realistically, what are our use cases? And I've worked with certain companies and we've actually ranked the use cases by a set of like weighted criteria. So this is really intense. You don't have to do it this way. You might say, oh, I have 5 really good use cases I'm going to start with. But like you want a way to identify high business value use cases and you start with those. But and the reason, and we weighted it because we were like, okay, how easy is it to solve for this use case, right? So if it's a super complex use case, that should not be the first one that you do, right? You want to kind of figure out from all of your use cases, how do I rank and sort these so that I'm hitting the low hanging fruit that's achievable within like like a 1 to 2 quarter, right? 3 to 6 month time period. That way you can show value fast. And then because it's not complex, you can build it right. Like you don't have to cut corners. Because sometimes when it's too complex, then you're going to be like, oh, wow, this is taking me 6, 7, 8 months. And I'm going to have to cut corners.
So I think there's a little bit interesting of an idea there, which is like, how do you, or what metrics are you monitoring
Right.
when you're looking at this, right? Like, as you're bringing it together and you don't know what the future, you're kind of like carving out the future. What then do you start to look at? What are the needles that you want to move?
Yeah. That's a good one. And I think Shamak actually, she addresses this in her book. I don't know, maybe like chapter 10. I don't remember, but it's called fitness functions, right? So you need to agree ahead of time, more or less, what is going to be your measures of success from the data mesh in your organization. And everybody has a different kind of fitness function, right? Like some are like centered around the developer experience. So like very technical organizations will just be like, if you can make the developer experience easier and more efficient, then I'm happy, right? Like if you can improve efficiency by 30 or 40% so that we're not building snowflake architectures over and over again, right? Because with a centralized approach, you do kind of get into that, like you're building on top of this central monolith and there's a bunch of system bottlenecks and you've got to kind of work around that. Or like you have all of your pipelines deployed to like one instance of Kubeflow, and then you have again, you kind of have this same problem. So you have to think about like what kind of your different like measurements of criteria. Now, on the other hand, maybe you have an organization that's not like is developer focused or like ML focused, and that it might be more about business value. So then you have to say, okay, like these data products that I delivered, like what is the utilization of the output ports of these data products by the business users, by the customers, right? And so you can measure that through survey, you can measure that through like actually just seeing who accesses it and how frequently. And so there's different, depending on the organization, there's different types of fitness functions. Maybe you do both, right?
Yeah. And I guess of course, each instance is going to be different. But as you're trying to set this up, I imagine that you're not going to be able to set it all up in one day. So how do you have how do you break up different metrics to know that you're making progress on like this bigger vision, right? So if it is, for example, I really like the one where it's the developer experience, because that I think a lot of people can relate to, and a lot of people have that dream. But then if it's a 3, 6, 12 month project, what are you looking at to be like, all right, we're making progress and it's better than the last iteration that we had? Like you're saying, does that just mean that we're not rebuilding these snowflake type architectures? But before you're at that end state, how do you know that that's where you're going to get to, right?
Yeah, this is like a philosophical question in a way, right? Like I'm kind of thinking through this, like how do I know what I don't know, right?
Yeah.
So, yeah, it's
Well, I guess, yeah. So I guess
so
the way that I'm thinking about it is like, you really got to just be bought in on it, right? And then know that there's going to be a payoff at some point. But is there things that you can see beforehand that can be like good indicators
yeah.
that there's going to be that payoff?
Definitely, definitely. Yeah, I got you. Okay, I understand now. Yeah. There are like so at the end you kind of we typically will do kind of a strategy piece first, like to kind of just like set up like this is the data mesh, this is kind of how it will more or less be organized. Like you're going to need a governance board, right? This is what we'll do. And then we kind of do like a roadmap, right? Like we set up milestones, right? 3, 6, 9, 12, whatever, right? Per quarter. And so you, at the same time though, you have to acknowledge that while you're building this data mesh, you're probably needing to keep business as usual going too, right? And so you're slowly taking pieces, you're slowly decomposing just like you would do with like a monolith into microservices. Well, you actually probably have like a giant data monolith that you're also decomposing as well. And so as you do that, you are going to have to slowly kind of take pieces out of business as usual and then convert them into various data products. Um, and and then, kind of like catalog them, that kind of thing. Um, I'm just thinking like what is a good way to measure that? I mean, a lot of times, people will send out surveys, that kind of thing. Another thing that we've done kind of internally is you evangelize the data mesh, right? So like every milestone, every few sprints, if you have a showcase, you make it public. Look, everyone, this is what we're doing. Now instead of hunting around in the Redshift instance, you can just go to the data catalog and search by keywords for what you want. And there's descriptions for every field, and there's summaries for tables, right? Even just simple things like that, just will give you high business value.
Yeah.
And one of the ways people are using it though is you take this idea of discoverability, right? And one of the central things is you have a data catalog. And so you can hook in analytics, like Google Analytics, for example, or you know what I'm saying, like different way, like to measure web traffic. You can actually kind of look at analytics on like what people are searching for, what data sets they're going to, how often are they using the tool, and you can use that to measure, in a way, an element of success. Because if people are using it and they're accessing the tool and they're like it's being highly utilized, that now, right? So that's one way from a central location you can kind of measure how the organization is adopting it, is by analyzing the web analytics from your catalog.
Yeah, that does come to me. That would be one of the major benefits of like looking at. There's an article from Spotify and a tool they built called Lexicon that gives them. Yeah, and it's like I think it's internal only, but it talks about how they can see who's using what data sets, like how they're getting used, and I think
Yeah,
that is again a dream state that we'd all love to get to. That's
right.
yeah,
Yeah, that's it. Yeah, that's it. Yeah.
loads of other questions. So we talked about starting small, quick wins. The a lot of the chat and like discussion always leads me to think though, is this reserved for big organizations? Is there because there's lots of roles that need to be involved, and as well as like doing it alongside BAU, we talked about boards and stuff. Like, is there a lower limit whereby it's not achievable, or is there a lower limit by which it's just not worth doing? Actually,
Yeah, there is. I tell people this too. Like when we'll go in and kind of like people will be like, okay, can you help me with my data space, that kind of thing. We go in and we don't just come in and be like, okay, you're going to use data mesh. I mean, sometimes like it's pretty obvious and it makes sense, and
Yeah.
you're like, yeah, yeah, of course. But you have to go in and you have to kind of do this, this I don't know, cost benefit, or you have to think again. Like even when we broke up the monolith into microservices, we knew that there would be a sacrifice of the simplicity of a
Yeah.
monolith, right? It's a single deploy. It's right. Like I know where everything is. It's one code repository, right? Like it's one API. It's simple, and that's fine. But so until you need to scale, uh, right, right, until you need to scale out, I'm not sure that it makes sense because remember that you are sacrificing kind of what is pretty simple, like a monolithic structure, for what has now a pretty complex network of like nodes and edges, and you have to enforce like interoperability between each of these and individual pipelines that build and deploy. So there is definitely like if you're like a the classic example is like a small startup that needs to be first to market really fast, and they have a pretty simple product, right? There is no reason probably for them to use data mesh until they turn into a high growth startup. And we've seen several clients like this, right? Where they'll be like, okay, wait, now my monolith is reaching all these bottlenecks, right? Like I'm streaming data into my data warehouse and it doesn't make sense. And it's like high transaction and high reads and high writes. And then it's like, okay, now we need to step back and we actually do need to look at data mesh seriously and break up that monolith into small, more manageable chunks. And then organically, it actually solves a lot of the system bottlenecks, which is
Okay.
interesting. But yeah, no, I don't recommend data mesh for every single situation by any means.
Follow on from that then, I guess. So, because my head was like initially, it's
Yeah.
scale would be the limiting factor. You need a lot of people, and like, what's the benefit? Almost like that
You do.
Conway's law type stuff. So,
Yeah.
other than scale, are there other like indicators for actually that's not it isn't the best approach? Are there other things that you would say, like culturally, technology choices, things like that, where you would say, oh, you probably shouldn't do this just yet or at all?
So I struggle with this one because I'm very like technical in my approach, right? And the idea of data mesh is that it's also like a social aspect, right? So like you said, it's Conway's law, right? If you have a highly centralized team, you're going to have a highly centralized system, right? And then that comes with its trade-offs. But then there's this weird aspect also of just culture. So if if you're trying to build a data mesh without also applying the operating model of a data mesh type organization, it's not like you won't get the benefits. So if you're just trying to do a technical non-socio implementation of data mesh, yeah, you'll probably get the benefits, right? Because at the end of the day, it advocates for best practices. It advocates for measuring the quality of your models. It advocates for, versioning, right? Like DVC, right? It advocates for all these good things that you should be doing anyway. So you get the benefit of that, but you don't get nearly as benefit as if you also applied the operating model. And in order to do that, you have to have the mandate from the top down. Otherwise, it just won't work, right? You can't change. I mean, you can't change the operating model probably like an engineering manager, right? Like you're going to really struggle with that. But you can control how you build your data pipelines and your data products, and you can control like adding quality metrics and like loosely coupling one data product from another. So there are some benefits that you get, but at the end of the day, there absolutely does need to be, if you want to do the full data mesh, you absolutely have to have the cultural buy-in and the desire, I guess, and the mandate to make some organizational change in addition to changing the way you look at architecture.
And when you were talking earlier about how to, like, basically when to make the jump at what scale, and you're small and scrappy startup, and then you go to this gigantic behemoth, and you want to make that jump at some point. Are there things that we can do in the beginning of our life cycle at that small and scrappy startup to set the foundation
so that when we do change, it's a much easier change?
Yeah. Yeah, definitely, for sure. And I think it just goes back to kind of what I was talking about, right? If you just do like if you just use some like what we call them sensible defaults on like how you should handle data. And that's not data mesh specific, right? I mean, data mesh advocates for all of those things for sure because it has the DATSYS, it's like discoverable, addressable, trustworthy, so on and so forth. But if you're good, let's say like custodians of the data, right? Like I think a lot of times when and this is I myself included, when I first started doing this, like the data scientists were developing everything in like Jupyter notebooks, and then like they would run ad hoc runs of the of the model training, and it wouldn't be automated or anything like that. And so like you know in this case for this context, right, if you're just practicing good CD4ML, even if you're a highly centralized like environment and you want to make the transition to data mesh, it's just that much easier because all of those things are still applicable in the data mesh. And a lot of times people aren't even doing that when they start their journey into the data mesh. And it's like, oh, now not only that, but you also need to do this, right? On like we're layering in like, oh, and now you need to add, some metric system by which you can measure drift in models, right? And
Yeah.
emit those metrics like a Prometheus or a Grafana or whatever, right? And so if you start doing things right from the start and using good data practices and good ML like practices from the beginning, which includes like testing and all of those things. If you start that from the beginning, then your transition to data mesh from a central kind of system will be a lot easier.
Yeah, because you can't do it without that, I imagine. It's
Yeah.
just like not
Yeah.
going to happen.
You wouldn't, yeah, you wouldn't be able to kind of like, you wouldn't be able to do the like self-describing, interoperable, secure, trustworthy, addressable, discoverable, right? All of those things, even though they're like kind of like descriptions or capabilities, those all tied to tools that you have to learn how to use.
So I feel like there's been quite a lot of like, because it's big and scary, right? It's a big scary thing. It's like it feels
Yeah.
like a lot of work. It's still finding its feet. No one's written the blueprint of how to do it really. It's kind of, here's some guiding principles, let's discover this together. Even the book says you've got to be an early adopter. So to put a big positive spin, just
Yeah.
from your experience, I'd love to hear like, are there unforeseen benefits that surprised like you or the team from a well implemented data mesh? Have you got like a cool sort of war story use case about like all they did it, and then for a data scientist thinking more about MLOps and data science professionals, were there like cool outcomes that no one had seen before that actually like would be a good reason to get excited about this stuff and put the effort in?
I would say, I mean, some of the various things that I've kind of like we've kind of encountered is that like specifically, and I kind of touched on this a little bit, but like as a data scientist, when I've worked with them before in the past, like the way we used to work was just like, hey, can you give me a snapshot of this database? Right. And so then the data scientist would be like, hey, can you sit down with me and explain to you what is this table? How do I do these queries? Like, where do I get this data from? You're like, well, you got to join it from over here. And right. And so when you have these data products, at the very least, you get a level of like almost like governance and standardization. So this is what surprises people, I think, because there is this like federated governance piece to this where you say, hey, look, you've got to measure data quality, but you only have to do it in these 4 areas, and how you measure it, that's up to you. Just make sure you measure it, right? Make sure it's there. And so also, by the way, all of these things need to be interoperable. Again, the team decides how they want to make it interoperable, completely up to them, but at a governance level, at least it needs to be interoperable. And so the governance layer actually is really important. And then when that like kind of like I call it governance light or federated governance, where you kind of where you just give meaningful guidelines. When you apply that, there are a lot of like hidden benefits of like not being too standard, but being standard enough that as a like someone who's in the like the ML like side or a data scientist, they can almost always count on the data being presented in a certain way. And because the quality is being measured of the data, you can actually trust the data. Because I remember a lot of times when I've worked in these co-source teams with the ML engineers and the data scientists and stuff, we would build a model, right? And train and test and that kind of thing and be like, oh, okay, yeah, this looks like it's working. And then we would productionize it, and the performance on it wasn't great. And what we didn't know was, like, was it the data, or was it how the model was trained, or were we just never going to get the performance on the model that we thought, right? And at least now you know that the source data that you're getting has some kind of quality check on it. Whereas before, you were like, I could imagine, like, as a data scientist, banging your head against the wall, being like, why isn't this working? I don't understand. When in fact, like, maybe the data that you originally got wasn't very good quality data, and so, garbage in, garbage out, right? So I think that's an added benefit, because there's the governance for the quality, and then the quality gets set up in an automated fashion, and you know that the data is more trustworthy. And so then I also have discovered that when we've run data quality checks over the data, which we thought was trustworthy, and we deployed the data product for the first time, and it was like, oh, I didn't realize that like 75% of this field that we thought was really valuable is all null, right? And then you go back to the operation system and you're like, hey, just notice this for the first time in a year.
Classic.
Classic null values getting in the way. But that's a weirdly common one, actually, is when you profile the data for the first time and you discover how, like, just kind of how trash maybe that column is, or the
There's a
field,
quote,
right?
I can't remember who it's from, but someone once said there was a quote around, anyone that thinks their data quality is good hasn't looked properly.
Yeah, I like that.
Like, there's no such thing. Like, data quality is never good.
Basically, yeah.
Yeah,
Never trust the data.
exactly. But you got to use that feedback to give, to tell the operations folks or the data engineers who are processing it through the pipeline, hey, not good, right? We got to fix this.
Completely. So, Shawn, man, this has been eye-opening. I really appreciate the way that you break it down, and you sat through some of our qualms and questions. I imagine you're getting this day in and day out when you're talking with people about the transformation and trying to go through the data mesh. It seems like you have some war stories. You have a lot of experience helping people make that transition and then seeing the benefits. I think this is where we're going to finish it. I've got one last question for you, and that is going to be a deeper one. So brace yourself. How do you want to be remembered?
Wow, that is kind of a deep one. Yeah. How do I want to be remembered? Oh, wow. I like this one. Well, I'm a philosophy major, so I'm really thinking on this one. How do
It's gonna get deep.
No, I mean, I think I want to be remembered as, someone who I love helping others. So I just want to be remembered as someone that, is just like a good person that helps others, right? Like a good Samaritan that's, trying to kind of further along like our like slow slog through the primordial slime of like learning like ML modeling and artificial intelligence and building data systems, right? Because I just feel like we're kind of in the space where like software engineering was like maybe 5-10 years ago, and now we're just kind of like everything is new and like we're figuring out how to use it. And I just kind of want to be there to like help, fight the fight of improving and being better. So
That's an answer I can get behind. Thank you so much, Shawn.
cool. Thanks a lot.